In this very short video, I will introduce you all the basic workflow to experiment a little bit with some bird flocking behavior inside the new Niagara, how you pronounce, system in Unreal 4, and hope you will enjoy. In the end, we will also experiment a little bit with point force. It's very fast and very simple setup that I just came up experimenting a little bit with the systems, and I think it can become pretty precise and interesting if you work with several forces and you use blueprints to drive simulation. You can simulate, for example, some basic avoidance and chase or attraction forces to get interesting movement inside your birds. And I will show you from Sketchfab model how I just used a secondary UV map to drive the shader for the wing simulation, and how to obtain some variation inside the different instances. Downloadable assets. If you scroll down, you can find Flying Crow Blacksmith Workshop asset. I think works pretty well, this one, so you can download it. Is by Kianos. You can download the Blender file. So if you go inside the Flying Crow Blacksmith Workshop asset, you can find some texture, normal and ambient occlusion, and you can find the original Blender file. We can open it, and so we have our model. We can check that it has UV. So basically it has a UV layout. So this workflow, you can directly change this one. In this case, the model, it doesn't have a real texture for color and so on, but maybe you have a more realistic bird, and so you want to keep this. However, also this one has some texture, so we can go inside the UV maps and create wing mask, another UV map. We can switch to this one, so we don't override this map. And basically we want to map all the UV on a gradient. We will use in the shader a gradient that will drive the vertex animation. So basically we want this part, so the attachment of the wing and the body, to not move, and gradually to move with the shader the vertices up and down to simulate the wings, the wing movement. So basically we can select everything and go here and do weld. So we just we will put them here. Don't go outside, just stay, for example, here. It doesn't have to be precise at millimeter, because we will keep at least this part black and then go towards white. So now we can start to create the layout for the wings. So basically we can select the edges and create the cut for our wing UV. Okay, so mark scene, and this part. Okay, sorry, not mark sharp, but mark scene. Okay, then we cut this part and this part. in, and we do the same here. Okay, so we have the wings, we select them. Sorry, let's use this, the face mode, it's faster. Pretty sure, okay. Okay, then here we can unwrap. We have the wings, so basically we have everything and the wings here, and we can actually keep the wings, rotate them, we bring that down because we want this one to be rotated like that, and this one, this one, yeah. Okay, so we have our wings. Yeah, we can make them a little bit bigger. The important thing, of course, it's not they can be in this channel overlapped because we have the original channel. In this channel they can be overlapped, but just try to keep this part on the black side. You can also just put all the points in a straight line, or maybe do like that. For example, select this point, scale x 0, and they just align. You can do also like that, but I think it's not necessary. But we can make them also overlap. Okay. And the important thing is that they stay inside our UV map. Okay. So we have our model, we export it FBX and export directly. Okay, now we go inside Unreal, we create a folder vertex, and we make a folder asset, we import our flying crow. We don't want to generate the light map, and we should check. Okay, we have our UV channel 1 that works like that. So basically we can check the model here, and we can start to create a material. We can say MT grow. We want to assign it directly inside the mesh. Okay, so we have our bird, and we can start to create the material. So the basic step that I did was to work on world position offset. So basically we can drop down a vector 3, so this will be the direction we want to move on the z-axis, the third. So basically, we will use this as multiply the scalar parameter that we will call movement. For the world position offset. So basically, if we say 10 here, you can see that the model is a little bit upper. You can say 250, more visible probably. As you can see, it's already moved because we made a parameter. So as you can see now, it's quite far from our place. So we just turn to 0. We will use basically this world position offset cycle through all the vertices and move by this number. We will use a sort of gradient to mask the thing. So we can take the texture coordinate. We can create a linear gradient. So we can check the result in this way. So basically, if we multiply it by a constant and we clamp it between 0 and 1, we can increase the results, or we can also, if we want, we can also use the contrast node, chip contrast. We promote to parameter and we say 2, for example. Maybe okay, and we can multiply this by this. So basically, if we change the movement in this way, you can see that if I add the movement, it will be quite messy, but because we just using the first channel of the coordinates, but we need to apply the second channel. In this way, you can see that now movement is connected with this part of the wings. You can change, as you can see, you can smooth the contrast. I think we can also set 0. This way it's the original one, and I think we should add a little bit of contrast, and of course this movement is too much because it will be in this way also. So here we made the mask, here we have the movement. The movement, we can check it with time. Multiply. Sorry, no. Yeah, this one of the movement, and we will have a secondary multiply for time scale. That one. As you can see, it's really small, but we can increase it. And our birds fly. We can increase the time scale to have it faster or smaller. I mean, I think with the gradient you can change a little bit the look, can look better. You can change, maybe you can also make the UV a little bit bigger here. So for now I think it works pretty well, because we will be seen from a fast view. It's not a close view. So we have our basic system for the bird. We will need to drive some stuff from the particle system. So we will start to import our texture, this to texture. We can use it. In this case, we can use texture coordinate to be sure at 0. And we can have the normal inside the normal. We can have the ambient occlusion. We can have particle color for the base color, and compile and check. and we can then change this, not this one, we can leave it like that, but we can change this to with the dynamic parameter. So basically we can have the first parameter can be time scale, second parameter can be movement, third parameter can be we can add because if we use the same movement and time scale for all the birds, it will just move the wings in the same way. This is the main problem, to give some differences to all the flocking system. So we can add at least ID variation 1, and we can that we will use for the time scale var time, and we can add a var move. So basically we can multiply these two, and the default value will be 1. Okay, we can multiply the second value is 2. We want the second value to be 0. Okay, so this can be our time scale, and this will be our move. So we can change this. We can change this. So I think that's enough for our material. It's quite straight, and we will use it inside Niagara. So let's go here, create a new folder, PT system. We can use Niagara system, new selected emitter. We can start from fountain, it's quite simple, and we call PT bird flocks. We open it and we place it directly inside the scene, so we can have a better view. So let's start from get rid velocity cone, get rid of gravity force. We can actually cancel them, and we can try with the sphere location. We can use also a box location, but I think it's quite okay. We can say 150, 150. Okay, our birth maybe too big. Let's say 100. Okay, so we can start to add so the flocks can do several stuff, like going for example in the sky like that, following a direction. We want we try to make for this time some birds that just fly circular on an area. So we will also make them appear and disappear very gently. So it's basically we can use a certain amount of particles to keep the effects always alive, just like environmental effects. But you can then make them pass through the sky and so on. It's the same. So we can, inside particle update, add vortex force. Just it will say, okay, pay attention, because if you Niagara works with the consequent stuff, so if you put it after the solid forces, it will be quite it will not calculate exactly. So we can say this. We don't want actually full amount. Too much. I want basically that the burst doesn't stuck in the center of the object. So I want to pull them outside. And something like that will work. We can actually use so we want to spawn much less particles, and we want them to leave more. So in the initialized particle we can set between 10 and 20. We want the so basically it's the tweak the forces. Okay, so you can see that when the particles spawn, they just they are stuck in a place, and then the vortex force started to make them work. So we want them to move a little bit, and we can say uniform ranged vector. We can say on the let's think that, for example, x and y are one direction, so we can say between 5 and 10, and then 10 minus 10, 5 and 10. So when they spawn, they just start to move. We are starting to getting some interesting results. Maybe more. Okay. We can add a little bit more variation in the movement with a curve noise force. If this error appears and you don't want to move by yourself, you can do fix and basically it should work by itself. We can increase a little bit curve noise force. It works. Seems to work. So let's start to add our actual bird. We drop down a mesh renderer. We get rid of the sprite render. We go inside our assets folder. We drop down our birds, and now, as you can see, a lot of birds coming in the scene. Too much. So let's say spawn rate 5. And let's start with facing velocity. So basically, as you can see, it turns down in the velocity, but the orientation is quite messy. So in the particle spawn, I think good things of Niagara is the steps. You have the different part of the life the system. So in the particle spawn, we can say mesh orientation to vector, and here we can try to experiment. As you can see now, our bird is completely messed up. We can say, for example, so it's not this one, it's this one, but now it goes back, so -1. And here our birds are aligned, finally. Okay, very good. So the main problem with orientation that you have is that, as you can see, if you have some velocity change that appear to abruptly, basically the orientation of the models, it looks strange. But the fact that the beginning starts like that, it's not so relevant for us in this case. So we can we should use the parameter now. So you have two different ways. You can, for example, change the shader, this shader. Sorry, not this one. I was wrong. You can change this shader to be driven by the time inside Niagara. I think in this way it's a little bit more tricky, because I tried to change the scene, the sinusoid blueprint, but I had some problems with the ID. It seems to refresh some parameters each frame. So I found that if you have a common time inside the shader, then we can add at the beginning the multiplier that will change each instance. So I don't know if actually in this case I think it's not important, the ID, because we will not use there was a previous version in which I used it, but I think this is more easy. You can go to particle spawn and use dynamic parameter. Why in particle spawn? Because when the particle is spawned, it will drive this and not on the update, because it will change constantly. So we have our time scale. We can do the time scale with dynamic inputs. We can say uniform float. So we can have 1, let's see, 1.5. We can have a movement uniform float between 20 and 30. Let's see, like that. As you can see, now our birds start to move the wings. And they are pretty much already different. We can add more variation. UE4 raised float. Let's say between 1.25 and also this one, raised float. Okay. Then we can add color. Sorry, was wrong. Color module here. We can choose this. Then you can see, if I, because with this it's quite strange. As you can see, it change basically the color between the different birds. I think the ambient occlusion is not so beautiful, so I will get rid of it. It doesn't add so much to the bird. So they change the color. We can use a little bit. They are crow at least, so they should be quite dark, I think. And so we have our crow, and we have our color. We can add a scale. In this case, I prefer to use multiply vector by float. This will take the scale and multiply by float, so you have basically a linear interpolation. It's not, because if you change two vectors, maybe you have some medium value between the different axes, and they change the scale. But in this case, you can then, this is the great things of Niagara, you can add a secondary level of variation here, and say, okay, just multiply between 0.25 and 1. So you have a secondary level of personalization inside the scale of the mesh. I think it works pretty well. Then I don't know, it worked, the color. I don't understand why they are so, I think, normal. Okay, so you can add a secondary level of changing. Say also 0.4. Okay, it was not selected. Okay, in fact, it was quite strange that didn't change. Okay, we can increase the drag, let's say 1. No, too much. Okay, I think the scale is a little bit too different between the birds. From one side it helps to give the idea, but I prefer to say 0.5, 0.85 here. Okay, last step that I would like to add is scale by scale mesh size. Should be like that, I think. This one can be also after the solve forces because it doesn't. You can say curve. And we can add values. 0, we want to be 0. At 0.1, we want to be 1. 1. Okay. Add Pn values to all the curves. At 0.85, we want to be 1. Okay. And at 1, we want to be 0 for everybody. So basically our birds appear and they populate. Of course, if you don't like the fact that the birds just scale, you can make them appear from one side and then came into the scene. It's pretty the same, but I think it's not so. If it's for an environmental scene, it's not so complex or so disturbing, but you can always decide. I think we are pretty okay. I would just change a little bit the mesh size. Less variation, too much variation, and I want let's say 0.75, 0.85. And we can increase this. So we have a much deeper layer where the birds appear. So this is the main system. We went through. I went through the birds, masking the part of the body. You can add several variations to all the flying birds movement. You can just try to change the different parameters. However, they are not moving the wings at the same time. That it's quite interesting. I like this movement, and I must be sincere. For an environmental effects, I don't feel bad the appearance of the birds, because it's just inside the movement. But if you want, you can also add some stuff, and you can also add some. You can fake some avoidance by adding a point force, for example, that you can then drive with another element from Blueprint. Maybe I will just do a video for that. So, if I make it very strong, as you can see now, they just they are shot. As you can see, they are shot outside. So if I say minus 500, as you can see now, they are attracted by our origin. I'm just using the origin, but I think as you can see, you can simulate this, and if you change dynamically the force, for example, I put 0, you can drive this stuff from parameters. For example, in the bird flux system, you can add let's say float, and we can add a vector. I save because sometimes it's quite unstable, and sometimes it crashes. So I can create rename force and rename position. And then you can inside this, this one, you can say, okay, this one will be driven by our user force, and simulation position will be driven by our position. And you can then animate all this stuff directly. So now it cooks every time, but for example, if you say, okay, no, because it's 0 0, if now we create a blueprint, and inside the bird flocks we create a Niagara particle system affect PT birds. We assign this one. We create a sphere that we call point attraction. We can inside the event graph get the PT birds, set Niagara vector 3, we should remember our this one position is called, sorry, I closed it. It's called position, and yeah, variable name position, and we can get our point of attraction that can be an object, get actor at location. Yeah. Compile. Save. And in this case, pay attention, this will not change anything now, because the blueprint works in play. What's this? But if we simulate the things, now we should hopefully move the point of attraction, and as you can see, birds just move towards it. No, that seems not to work. Yeah, seems to work a little bit, but why? Let's check. Yeah, seems to work. Position is the variable. Position. If you go inside the blueprint, the force was set to 0 inside the PT birth. You can also automate this process or change it, but of course if it's 0, the point of attraction doesn't work. But as you can see, now the birds follow completely the point of attraction. So you can simulate, for example, something that attracts the birds, and something that doesn't attract the birds. Pay attention to as you can see, if we go close to the center point, they will be attracted. If you want it to work with all the stuff, increase the radius. You must use the radius, but you can use it also, for example, to simulate a basic avoidance. For example, using 250 instead of as you can see now, birds just escapes from it. So you can use this to change the behavior of the flock. Okay, I think this is really simple and basic usage of flocking system in Niagara, but I think it's a good starting point to create some more complex and interesting behaviors.